A very good evening to one and all. As you all know, I am your Basha. Welcome back to our channel, Maths with Khadir Sir. As you all know, we completed the exercise 1.1 of chapter Real Numbers of class 10. Today we are going to learn the most easiest, the most important theorem of real numbers. That is what? Prove root 2 is irrational. So as you know the rational and irrational numbers, let us start how to prove this theorem. First, what they given, they are asking us to prove root 2 is irrational. In our mathematics, to prove anything we go against of the given statement. So let us take, let root 2 is rational. Root 2 is rational. So we know that rational is in the form of p by q, where q is not equals to 0. Yes, p by q form and q is not equals to 0. And the next one is the p comma q are co-primes, which means the p and q having only the common factor is 1. So let us take root 2 is irrational. So after taking root 2 as rational, root 2 is equals to a by b or p by q. Whether take p or p by q or a by b, no problem. Now to remove this root, we have to square on both sides. Squaring on both sides. Now root 2 is equals to a by b square. 2 is equals to a square by b square. Now let us take this b square to this side. 2b square is equals to a square, and take this 2 to this side, a square by 2, and take this as number 1. Now you know that theorem 2, that means let p be a prime number and a divides p square, then a divides p also, where a is a natural number. We completed that theorem 1.2. Basing upon that, see here 2 is a prime number and a is a natural number. So if p divides any square, then it divides it a also. So let us write, if 2 divides a square, it divides a also. A also. So that take a is equals to any integer 2c. Now substitute this a in here. That means b square is equals to a square by 2, where a square is equals to 2c square by 2 b square. B square is equals to 4c square by 2. Here in 2 table 4 2 times, b square is equals to 2 square, 2c square. So b square by 2 is equals to c square. If you observe that here 2 is dividing a b square also. If 2 divides b square, it divides b also. But if you observe our conditions, pq are co-primes. Pq are co-primes. That means the p and the q are having only one as the common factor. But here we are having, except one, we are having here 2 also as common factor for a and b. So that our assumption is wrong. Therefore, root 2 is irrational. This is how we have to prove root 2.